Hey everyone. Here's another problem that it seemed like people had a lot of trouble with. I think this one was on the homework, but again, a lot of people really missed this one, so I do want to take a second to go over this. Let me pull up a new sheet. This asks us to find the domain of the following function. Do not use the graphing calculator. I think one problem that people might have with this is they might not be able to factor. So we're going to talk about that a little bit. I'm going to probably attach a few videos, but if you cannot factor a polynomial, that's one of the skills in this course that we're going to assume you know how to do. Okay? I will include a few links of how to factor below, but if you don't know how to factor, it's really, really important that you look over those videos and you kind of refresh that with yourself. If you are really, really having trouble with factoring, you need to get in the math lab and tell them, hey, I'm not very good at factoring and I need some extra practice. So this problem, x squared minus x minus 6, we need to factor the denominator. And to factor the denominator, what we do is we look for factors. If there's no number in front of x squared, which there's not, so there's no coefficient out here, we're going to multiply. We're just going to look at the last number, negative 6, and we want to find factors of negative 6 that add to the middle number. So we want to find factors of negative 6, again, because that's the last term, and the factors of negative 6 that add to the middle coefficient. The coefficient in the middle is what? What's the number in front of the middle term? So that add to negative 1. So what are the factors of negative 6 that add to negative 1? Those are, it would be what? It would be negative 3 and positive 2 multiply to negative 6, and they add to negative 1. So those are the factors here. Oops. So we can factor this the bottom of this rational expression as, oops, yeah, and this is kind of strange because it's going to be x minus 3 and x, since it's a positive 2, it's plus 2. Oops. So this is this equation factored, and now to find the domain of a rational expression, we set the denominator equal to 0. So we're going to set this expression. We're going to set x plus 3, x minus 2 equal to 0. And how do we solve expressions like that? Well, we set each of the two factors equal to 0. So we're going to set x minus 3 equals 0, and we're going to set x plus 2 equal to 0. And we solve these. When we solve this, the left side, we're going to get x is equal to 3. And on the right, we're going to get x is equal to positive 2. I'm sorry, not positive 2. We subtract 2 from both sides and we get x is equal to negative 2. So we know that those are the numbers that x cannot equal, because those are what are going to make us have a 0 in the denominator. And we have a 0 in the denominator, that's when things really get screwed up in our domain. So these are what we need to leave out of our denominator. So when I go over here and I write the domain, what we need to do is we need to leave negative 2 and positive 3 out. So x can be all the way from anything from negative infinity all the way up to the first value we have to leave up on the number line is negative 2, right? And then I need to put a union here to let myself know that I have another piece. I can have also everything between negative 2 and positive 3, right? Finally, I can also have everything from 3 to infinity. So take a look at this. When you look at this interval, you see over here we say we have to leave out negative 2 and we have to leave out positive 3. So this is how we represent leave out negative 2, is we kind of just skip it over in this interval and make these two intervals. And we leave out positive 3 by putting this skip here as well. If we check our answer, we see we get the right answer. Again, go back to the video for 1.2 if you're having trouble with these domains. And the coordinator, Sandy, does a really, really great job of laying this all out. So please check out that 1.2 video if you're still having trouble.